Arc welding, it is a fusion welding process. Here, an electric arc is used as the heat source. An electric arc is a continuous stream of electron flowing between two electrodes into a medium. This gives rise to intense heat generation. This is used to melt the surface and deposit the metal from the electrode, resulting in a joint on cooling principle. The source of heat for arc welding process is an electric arc generated between two electrically conducting materials. One of the workpiece material called electrode is connected to one pole of the electric circuit, while the other workpiece, which forms the second conducting material, is connected to the other pole of the circuit. When an arc is struck between a metal electrode and the work, the arc heats the metal and forms a pool of liquid. The electrode material can be either non-consumable or consumable. The non-consumable electrode made of tungsten, graphite, etc. serve only strike the arc, whereas the consumable electrode, which is made of the same material as that of workpiece, strike the arc and gets consumed. The electrode gets consumed as and when the metal is deposited. The liquid pool of metal makes the work and becomes a part of it. On cooling, solid metal of homogeneous bond results. A joint is formed. The distance between the tip of the electrode and the work through which arc is formed is termed as arc length. Metal arc welding. It is also referred as consumable arc welding. Arc is struck between the work and electrode, which melts and furnishes the required feed metal. Both the rod and the work melt. Both AC and DC supply can be used. Arc supplies the required heat. The temperature and the heat input can be increased or decreased by increasing or decreasing the arc current. High arc current and low arc length produces high intense heat. The metallic rod is normally coated with a flux. The flux coating melts and produces slag, which covers the molten metal at the joint. The slag formed will also give the arc stability. An arc length of 0.6 to 0.8 times the electrode diameter yields high quality weld. Flux shielded metal arc welding. The welding is carried out manually and then it is referred to as manual metal arc welding. Weld bed, bead, well deposited metal, slag, gaseous shield, arc column, electrode, direction of travel, electrode holder, spring, flux coating, globules of molten metal, arc crater, workpiece, AC or DC, power supply. The surface of the work is cleaned to remove dirt to obtain a sound weld. The workpieces are held in position. Welding leads are connected to the power source and the workpiece. Power is switched on and a suitable current is allowed to pass. Electrode is gripped by means of a holder and strikes the arc by moving the electrode near to the workpiece. The arc length is adjusted such that continuous stable arc and supply of molten metal. During welding, slag is used as a protection to the molten metal. Flux acts as a shield to the weld portion. This is referred to as flux shielded metal arc welding. Tungsten inert gas welding. An arc is struck between the non-consumable tungsten electrode and the workpiece. in the presence of an inert gas such as helium or argon, which is passed near the arc, thereby creates a shield. This is referred to as tungsten inert gas welding. A filler rod is used to supply molten metal to the joint. Figure shows the TIG welding. Pressure of the gas varies between 0.1 to 0.15 Newton per square millimeter. Mainly DC supply is used. Filler metal, gaseous shield, collet, shielding gas to power source, shielding gas from cylinder, torch handle, tungsten electrode, weld and workpiece. Advantages: suitable for thin metals, clear visibility of the arc provides the operator to have greater control over the weld. Strong and high quality of joints are obtained. No flux is used. No slack formation results in clean weld joint. Disadvantages: TIG is most difficult process compared to all the other welding process. Skilled operators required. Process is slower, not suitable for thick metals. Application: TIG welding is most commonly used to weld stainless steel and non-ferrous materials such as aluminum and magnesium. Aerospace industry is one of the primary user. Refrigerators, air conditioners and chemical plants are other users.